Warning, the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This is a video in a series for pre-calculus students who are reviewing trigonometry to kind of continue through their pre-calculus course. And just to let you know, I've mentioned it before, but if you find this material to be too fast for you, it's because it is assumed that you have seen or had a full course of trigonometry prior to watching these videos. So most of these are just review, quick, dirty review. There are some sprinkled throughout that are actually full-blown lectures, but this is one that still is a review. So you should know about angle measures, and this is just a review of them. So let's talk about them very quickly here. All right, standard position. So an angle is considered to be in standard position if its vertex is located at the origin and its initial side extends along the positive x-axis. This is just a definitional thing so that you know that if your instructor says, hey, we've got an angle of, let's just say 135 degrees and it's in standard position, that means that the initial side, the ray that it emanates from or opens from, is the positive x-axis, and its terminal side is that 135, where that 135 degree angle terminates. And so that would be an angle in standard position. What really is the critical thing to note here is that the initial side right here is the positive x-axis. So if I were to superimpose a y-axis here and an x-axis here, then you could see that that is definitely the positive x-axis. That's just a definition thing so that we're all speaking the same language when you're in a math course. The next item up is just a discussion about positive and negative angles. You should have already seen this actually in a previous video. I don't know why I snuck it in on this one as well, but positive angles open counterclockwise. So that's a positive angle. And negative angles open clockwise. So that's a negative angle right there. So that's just an important note. It's going to be critical for the rest of trigonometry and pre-calculus. So just to remind you, that is true. Another definition, and this one you may not have heard of, but it's a quadrantal angle. An angle whose terminal side lies on an axis. I also call them axial angles, but I guess officially they're called quadrantal angles. I will probably still call them axial angles, to be honest with you. So these are things like 90 degrees or 180 degrees, that type of thing. So, or even negative 90 degrees, right? So those are quadrantal angles. But really the critical piece you need to understand when you're in pre-calculus and heading towards calculus is that calculus really only works well in radians. So if you are in love with degrees and if you hate radian measure, you'll have to get over that because radian measure is the way to go with calculus. So a radian is defined to be the measure of a central angle of a circle that intercepts an arc equal in length to that circle's radius. Well, this one I think merits a little bit of a picture. So here we have some angle. I'm not telling you what that is, but it's not going to be in degrees. Okay. And let's pretend the measure of the radius of the circle that this belongs to. I could draw in the circle, I suppose. And let's suppose that the measure of the radius of this circle is, well, let's just say 5 inches, 5 feet, 5 meters, doesn't really matter. We'll just say it's 5. That's the measure of the radius. And if we happen to be able to cut out an arc length of 5, then that very special angle that gives us that arc length that's equal to the radius of our circle is considered to be 1 radian. 1 radian. And radians are a unitless measure. So usually when you see a radian, it does not have a symbol on it. It just looks like a regular number, like these 5s or something like that. So you have to worry about the context in which you're working to know whether you have a radian or just a regular number, which is also known as a scalar. And as you might recall from your prerequisite course, a full circular rotation is 2 pi radians. Let's see why that's true. Well, if 1 radian is the angular measure needed so that the radius of the circle matches the arc length cut out of the circle, and if we can agree that it actually doesn't matter, that angle will not change if you change the radius of the circle, that is, this angle right here that you see will not change if I change the radius and the arc length to be, let's say, 1. Should still be the same angular measure, no matter what. And if that's the case, then we can use the fact that we know the circumference of a circle is 2 pi times r, and in this case right here, the circumference would be 2 pi times 1, or 2 pi, which means if we were to head around this entire circle, the angle in radians that would get cut out by that full rotation would be equivalent to the arc length. And the arc length we just said is 2 pi, so therefore the angle must be 2 pi. And that is why there are 2 pi radians in a full circle. Again, I want to reiterate that it would not have mattered if this was a radius 10 circle, as long as we still had an arc length of 10 right there. The angle in radians would still be, that 1 radian angle would still be the same. And if you look at the circumference though, the circumference would have changed, obviously, but the angle itself would not have changed. So the fact that we kind of scaled it down to 1 is very helpful for our argument. So having this as a scale of 1 allows us to talk just about what is that angle and how many of those angles will fit in a full rotation, which is 2 pi. Well, now that we recall that 2 pi radians is a full rotation, then we can recall that 360 degrees therefore must be 2 pi radians. And if you want to divide both sides by 2 pi, you would get 1 radian is equivalent to 360 degrees over 2 pi, or in other words, 180 degrees over pi, which is exactly what I have here. 1 radian is 180 degrees over pi. On the other hand, if you wanted to take this equation and maybe solve for 1 degree, you would divide both sides by 360, and you'd get 1 degree is equal to 2 pi over 360, or in other words, pi over 180 radians. And that's exactly what we have here. Those are the conversion factors between degree measure and radian measure. You do have to use those every once in a while, so you have to kind of get used to it. We'll use that throughout this video series. And you should just recall how to do that. So let's go ahead and convert some of these as our kind of final topic in this angle measures video as a review. So if you want to convert from degrees to radians, you would take off that degree symbol and just call it a 1 degree. And then we know that 1 degree is the same thing as pi over 180 radians. So that's 45 times pi over 180 radians. Notice there's no units there because radians, that's a unitless measure. And 45 goes into 180 4 times. So this is pi over 4. So this means that every time we see 45 degrees, we could also call that pi over 4 radians. You guys remember that from your trig? And then this, converting this guy, we're going to convert it from radians. So this is pi over 6 times 1 radian. And we're going to change that into degrees using the conversion that 1 radian is 180 degrees over pi. Notice the pi's cancel. 6 goes into 180 30 times. So this is 30 degrees. And you get the point. You can go all day long here, right? Pi radians, you would just write that as pi times 1 radian. And 1 radian, again, is 180 degrees over pi. And the pi's cancel, and you see that pi radians is 180 degrees. And then you have something like this. Notice there's no degree sign, which means that this is in radians. So this is 3 times 1 radian, and 1 radian is the same thing as 180 degrees over pi, and therefore you can go ahead and multiply through, what is that, 540 degrees over pi? That's as good as it gets. You can't really do very much else with that. You could obviously grab a calculator, but not worth it here. Just leave it in exact form. So there's some examples on how to convert between the angle measures. All right, that does it for this kind of review of angle measures. In the next video, we're going to attack arc length, which will be not new, but I'm going to treat it sort of like it is. And then we're going to go into brand new material.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.